There are proofs to these things. I'm not going to do them in brief calculus because we do it so briefly. There's a rule, and you need to know the rules. If I have the quotient of two functions, for example, if I had 5x plus 1 over x squared, again, since these are two simple functions, I could use algebra on this and use power rule on it. In other words, monomial division, where I would write this as 5x over x squared plus 1 over x squared. This would then be 5 over x plus 1 over x squared, which is 5x to the minus 1 plus x to the minus 2. Then I could use power rule on it. So I could use algebra on it. But quotient rule actually makes life a little bit nicer in some instances. And besides, our problems are much more complicated. So if I have 5x plus 1 over x squared, that is the quotient of two functions. Here's the rule. df dx, or f prime of x, is if you had g of x over h of x times g prime minus g of x times h prime over h of x squared, as if this makes any sense at all. It doesn't make any sense to me. However, if I remember this as the numerator over the denominator, what that formula says is you bring the denominator up. And then remember, it's related to product rule. So it's going to look a little bit like product rule. I bring the denominator up. Don't do anything with him. Take the derivative of the numerator minus the numerator times the derivative of the denominator all over the denominator squared. And you might say, why is there a minus sign there? Now remember that when I was messing with this guy, I said I brought the denominator up. He had a positive exponent. But when I brought him up, he has a negative one. And when I take the derivative of the denominator, this would be a minus 1 coming down. Where this would have been a plus in between, if I use product rule, if I'm going to multiply and take the derivative of that denominator, it's going to be minus 1 times the derivative of the denominator. That's where that minus comes from. Because it's the numerator times the derivative of the denominator, that denominator brings a minus 1 in here. So I just remember, it is very, very much like product rule. Everybody gets a turn. But it's like one of these things when you were in school, and what you did is you tried to remember a poem or something that you had to recite, right? Sometimes you couldn't remember the first couple of words, but if you got those first few, it just flowed after that. Well, this is what I learned teaching calculus, believe it or not, is bring the denominator up. So to me, visually, in my little puny brain, I reach down, I bring the denominator up. Once I know I bring him up, then the next thing I do is take the derivative of the numerator, and then it flowed. Because in its minus, well, I've already differentiated the numerator, so who's the next guy that has to be differentiated? The denominator. So the numerator stays the same, differentiate the denominator, then all over the denominator squared. So that's how I remember, that's how I now remember it. Visually, I bring it up, and then everything flows from then on. Now, if you look at a lot of other videos from other places, and one of my students, when I was teaching calculus over at ASU, one of my students over there said, I remember it as a yodel. As a yodel. And this is high.
Do you have an example of that yodel?
Yeah, divided by low. And it is low D high minus high D low all over low low. The low is the denominator, the high is the numerator, so it's low D high minus high D low over low low. And I actually was watching videos the past couple of days in which that's what they did. So, yeah, so that's a yodel. So for me, I just remember bringing I'm so good at product rule that if I remember to bring the denominator up and it's the numerator gets differentiated first, I'm okay with the rest of it. But doesn't matter how you do it. And if maybe you're going to be one of those, once we do chain rule, is that all you'll ever do is product rule like me. And that's okay too. I will never say to you, use quotient rule 2. Use product rule 2. You're going to find whatever method is best for you is what you're going to use. And for me, it was always product rule because I couldn't remember quotient rule. Till now. Now I remember it. I remember that. And I don't do well with the yodel, so to me, it's what I've typed in. Now, here's my examples. Here's your numerator, here's your denominator. Remember, these guys are in parentheses. They're more than one term. So when you go to differentiate them, you're differentiating that whole set of parentheses. So since this is y equals, I'm going to say y prime is, bring the denominator up, times the derivative of the numerator minus the numerator times the derivative of the denominator all over the denominator squared. Bring the denominator up times the derivative of the numerator minus the numerator times the derivative of the denominator all over the denominator squared. Low D high minus high D low over low low.
And that doesn't need to be, when we bring the denominator up, we don't have to put it to, raise it to -1.
No.
Just put it there.
The -1 is taken care of right there.
Okay.
That's that -1 power. It's built into the formula, which is good news. And then we're not going to, at this point, simplify it all away, but we're just going to go ahead and just take the derivative. And it's the numerator times, what's the derivative of 2x minus 3? 2. Minus the numerator. What's the derivative of 5x plus 4? 5. All over the denominator squared. And then that's where you're going to leave it. Reason why I emphasize just taking it to the first step is this. You're just learning the process. And in the process of just learning the process, you need to be able to work as many problems as possible. Simplification is not a big issue at the moment. It will be shortly. But if I spend all my time on algebra trying to get the answer that's in the back of the book, which is another reason why I also give you the solutions manual. If I try to do nothing but what's in the get my answer in the back of the book, I'm going to spend hours doing my homework making algebraic errors. If you then take it down to the first step like this, then go back to the solutions manual and then you look to see what the first step is of what they did and you say, do I have the right first step? You say yes, then you move on to the next problem. We are going to be worrying about simplification later, when it matters. Right now, you want the process down. What you want to be able to do is work tons and tons and tons of problems. Get through your homework just like that. Now, the problem is also going to be is that when you do the quiz, you're going to have to simplify. So you'll get the opportunity to do it on the quiz. But right now, and even on the test, I'm going to tell you, take it to the first step and leave it. Because I don't want you messing with simplification except where you have to. On the application problems, you have to. Don't have a choice. But on the then I don't have to care what the derivative the problems look like that I give you. If I say leave it at the first step, then if it's a mess, it's a mess. There we go. Y prime. Bring the denominator, remember, it's more than one term, so it's in parentheses. Bring the denominator up times the derivative of the numerator minus the numerator times the derivative of the denominator all over the denominator squared. So this right now is going to be my answer. 1 minus t squared times, what's the derivative of t squared plus 1? 2t minus t the derivative of t squared.
I'm sorry, I was looking at the next one.
Oh, okay. Phew. Plus 1. What's the derivative of 1 minus t squared? Negative 2t. All over 1 minus t squared squared.